can you see now?
Yes, miss.
Okay, acha. What about my mic? Is it okay?
Yes, miss. It's okay.
Okay. So we started this relative maximum or minimum in our last class. And we have gone through these definitions. Definition of relative maximum and minimum, then critical point, then stationary points. Then we have gone through two theorems, and then the first derivative test to determine whether there is a maximum or minimum at a critical point. These graphs were discussed in detail, and we have done a few math on finding critical points and to classify them whether they are stationary points or not. And this was our second derivative test, but we didn't do any problem on this second derivative test, and also we didn't do any math on finding relative maximum or minimum. Okay, these were the problems that we have done in our last class. We have gone up to page number 9. Page number 9. Okay. So here, yes, it will go up to 10. Yes, this is our next question. Here, this is the question. Use the given derivative to find the critical points of f of x, and at each critical point determine whether a relative maximum, relative minimum, or neither occurs. Assume in each case that fx is continuous everywhere. So you see here the values of the function is not given. Here the first order differential coefficient of the function is given. Use the given derivative. That means the original function is not given. Here the derivative is given, and it is given that we can assume that the function, the original function, this is the derivative, but it is given that original function is continuous everywhere. Okay, so here we don't need to find the derivative because the derivative is already given to us, but not the original function. So let us see here. At first we have to find the critical point, then decide whether it is a stationary point, and then we have to determine whether there is any maximum or minimum at the critical point. So here this is our derivative, and you know the critical points occur when either when f prime x equal to 0 or f prime x does not exist. There are two criteria for finding the critical point. The first criteria is f prime x equal to 0, or the second criteria is f prime x is undefined. So here you see f prime x will be equal to 0 if the upper part is 0. That means 2 minus 3x equal to 0. So x will be equal to 2 by 3. Okay, and this f prime x does not exist when x equal to minus 2, because when x equal to minus 2, the lower part becomes 0 and f prime x becomes undefined. So what will be our critical points? Our critical points will be 2 by 3 and minus 2. 2 by 3 and minus 2, and in between these two critical points, 2 by 3 will be the stationary point. Minus 2 is a critical point, but it is not a stationary point. 2 by 3 is a critical point, and as well as it is a stationary point. Okay, now to determine whether there is a relative maximum or minimum, here we are starting with the second derivative test. So that's why you have to find the derivative of this f prime x. That means second order derivative. Here this is a rational function, so you have to apply the quotient formula. The upper part is your u and the lower part is v. What is the formula? In the denominator, you have to write v squared. That means cube root of x plus 2 whole square. In the upper part, v into d dx of u. That means this cube root of x plus 2 into d dx of this. D dx of this means minus 3. Then minus the upper part, 2 minus 3x into d dx of this. What will be the d dx of this? The power is 1 by 3. So consider this x plus 2 as your single x. So it will be 1 by 3 into x plus 2 whole to the power 1 minus 1 by 3. No, 1 by 3 minus 1. Yes.
1 by 3 minus 1. Yes,
Yes,
miss.
1 by 3 minus 1, it will give you minus 2 by 3. And the derivative of this x plus 2 is 1, so just this into 1. Okay, now you do some algebra. Let us do some algebra here. You can take x plus 2 whole to the power minus 2 by 3 common. So here remains minus 3 into x plus 2. Because here the power is 1 and here it is minus 2 by 3. After adding the powers, the power will be 1 by 3, which is it here. Okay, and here what remains? There remains minus 2 minus 3x divided by 3. Okay, now you take the LCM and you do simple algebra. Finally, the expression for the second order derivative becomes this. So now you have to find the values of this second order derivative when x equal to minus 2 and when separately when x equal to minus 2 and when x equal to 2 by 3. If the value of this second order derivative is less than 0, the function original function will have a maximum, right? And if the value of this derivative at a particular point is positive, then the original function will have a relative minimum at that point. So let us find when x equal to 2 by 3. Yes, just put here x equal to 2 by 3. X equal to 2 by 3. So here it becomes what? 12 into minus 2, that means minus 24. The lower part is positive because here you see here under the cube root it is a positive number and the power is 4. So ultimately the cube root of this positive number will be a positive number. So there is a negative sign only in the upper part, so it is negative. Since it is negative, the original function will have a relative maximum at x equal to 2 by 3. Okay, now let us see what happens when x equal to minus 2. Just put it here. This was our expression for the second order derivative. If you put here x equal to minus 2, you see the lower part becomes 0 and the second order derivative becomes undefined. This becomes undefined. So in this case, the second derivative test fails. So you have to go back to the first derivative test for the point x equal to minus 2. So let us try with the first derivative test at x equal to minus 2. So let us make a table. You have to take a point which is just less than minus 2 and which is just greater than minus 2. That's why we have make a 3 column here. For the first column x, for the second column f prime x, because you have to determine the sign of f prime x. Here the expression for f prime x and here the sign of f prime x. So at first you have to take a number which is less than minus 2. So here I am taking minus 2 minus h. Remember this h is a positive number and h is a very small number which is very close to 0, but h is a positive number. These two things will help you to determine the sign of f prime x. These two are very important. H is a positive number and H is a very, very small number.
And always, age is always positive.
H is always positive, right? So because you have to take a point which is less than this point and another point which is greater than this point. So always we will take a number which is very, very small but which is positive. Okay, so here I am taking x equal to minus 2 minus h. So here just put x equal to minus 2 minus h. In the lower side minus 2 minus h. You see minus 2 cancel out. In the upper part you have what? 2 plus 6, that means 8, and this minus n and this minus n gives you plus sign. So in the upper part you have 8 plus 3h and in the lower part cube root of minus 8. Now determine the sign. What will be the sign of the upper part? H is positive. Remember, H is positive. So the sign of the upper part will be positive. I have given the sign here. The sign of the upper part is positive and the sign of the lower part, definitely it will be negative because H is a positive number. So minus H is a negative number. And when you take the cube root of a negative number, the result is negative. Do you understand it?
Yes, miss.
Yes, because you
Yes,
know.
ma'am.
Yes, because you know cube root of 8, that means 8 to the power 1/3 is 2. But if you take the 1/3 power of -8, the result is -2. Remember it, when you take uh, 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 cube root of some positive number, the result is positive, and cube root of some negative number, it is result. The result is negative. So the upper part gives you positive, the lower part is negative. So finally, the sign of this f prime -2 -h will be negative. Okay, because plus divided by minus, it will be minus, negative. Now we take a point which is greater than -2. So -2 plus h, again h is a positive number, h tends to 0. So now put here x equal to -2 plus h. So the upper part becomes 2 plus 6, that means 8, 8 minus 3h. And in the lower part, -2 cancel out, it was plus h. So lower part becomes cube root of h. And upper part 8 minus 3h. Remember, h is positive and h is a very, very small number. So the upper part will be definitely a positive number because h is a very small number, positive and small number. So the upper part is positive and the lower part is also positive because h is a positive number. Cube root of h is also positive. So here you are getting positive sign divided by positive sign. That means the sign of this f prime -2 plus h will be positive. So you see how the sign of the derivative is changing. It is changing. Before the point -2 it was negative, and after the point -2 it is positive. That means the derivative is changing its sign from negative to positive at the point x equal to -2. So the original function will have a relative minimum, because you know, when the derivative of the function at a particular point changes its sign from negative to positive, the function will have a relative minimum at that point. So since its sign changes from negative to positive, fx has a relative minimum at x equal to -2. So this is the way how to apply the first derivative test. Now you have another math. Here the derivative of the function is this. Ln of 2 by 1 plus x square. Ln means log with base e. This is the derivative of the original function. Now the function fx will have a critical point where if f prime x equal to 0 or if f prime x is undefined. So here f prime x will be equal to 0 when this ln of this becomes 1. Why? When this whole thing becomes 0, and this whole thing, this argument should be 1, because you know ln of 1 equals to 0. Ln of 1 equals to 0. So f prime x will be equal to 0 when this 2 by 1 plus x square equal to 1, because ln of 1 equals to 0. Now solve this equation. 1 plus x square will be equal to 2, so x square will be 1, so x will be plus minus 1. So this is the critical point, and it will be, these 2 points will be also the stationary points, because when x equal to plus minus 1, f prime x becomes 0. Now let us check whether there is any point where f prime x is undefined. Now, f prime x will be undefined if the argument of this ln is negative, 0 or negative. You know, ln of 0 is infinity, and ln of any negative number is infinity, positive or negative. So here, can it be 0 anywhere?
No, miss, x is
No.
No, miss.
No. So this argument cannot be 0. Now check whether this argument can be negative anywhere.
No, miss.
No.
No, miss.
Because the upper part is positive, it is a constant plus 2, and in the lower part there is x square. So for any real value of x square is positive, ultimately 1 plus x square is positive. So there is no possibility for the argument to be negative. So we have no point where this function, derivative of the function, becomes undefined. So we have only 2 critical points, plus minus 1, which are also stationary points. Now we have to find the second order derivative, because we are here we are applying the second derivative test at first. So what will be the second derivative of this function? You see, what is the derivative of ln of x? Please tell me.
1 by x.
1
One.
by x.
Okay, so you consider this whole thing as your x. That means it will be 1 over x. Ln of x means 1 over x. That means 1 by 2 by 1 plus x square. But since this thing is considered as x, so you have to multiply the thing by what? D dx of 2 by 1 plus x square. So this is your second order derivative. 1 over x, this was your x, and into d dx of this function which has been considered as x. So it becomes 1 plus x squared divided by 2. This 2 is a constant. You can take it outside. So it will be d dx of 1 plus x squared whole to the power minus 1. Now, outside it is 1 plus x square, and what is the derivative of this function? Again you have to consider this whole 1 plus x square as your x. So x to the power minus 1, that means it will be minus 1 x to the power minus 2. Your x is 1 plus x square, so you have to multiply it by d dx of 1 plus x square, and d dx of 1 plus x square is 2x. So it becomes what? Minus of 1 plus x square divided by the power is negative. So you can take it to the lower side. It will be 1 plus x square whole square. And here the d dx of this is simply 2x. Okay. So 1 power is cancelled. So the expression for the second order derivative is minus 2x. It is minus 2x divided by 1 plus x square. So this is our second order derivative. Now we will check the values of this second order derivative when x equal to minus 1 and when x equal to plus 1. So let us put here x equal to minus 1. So it will be minus 1 into minus 2, it will be plus 2 divided by 2, which is 1, and it is positive number. It is positive. And when you put x equal to 1, it becomes what? Minus 2 into 1, that means minus 2 by 2. It is minus 1, so negative. So what will be our conclusion? The function, original function, will have a relative minimum because it is positive. It will have a relative minimum when x equal to minus 1, and the original function will have a relative maximum when x equal to plus 1. Okay. Now, this is our next math. This is the derivative. So this is these are exponential functions, so it is continuous everywhere, and the original function is also given that it is continuous everywhere. So let us find the value of this function derivative when find the value of x when this becomes 0 or undefined. So f prime x equal to 0 when this whole thing equals to 0. So you have to solve it. Let us suppose that e to the power x equal to y. So it will be y square minus 5y plus 6 equal to 0. Find the factors. It will be y minus 2, y minus 3, and so the values of y equal to 2 and 3. Y means what? Y means e to the power x. So e to the power x equal to 2, which gives you x equal to ln of 2, and e to the power x equal to 3, which gives you x equal to ln 3. These are the critical points, and they are also stationary points. Now let us see whether there is any point where this derivative becomes undefined. No, there is no point because exponential functions are continuous everywhere. So there is no point where f prime x is undefined. So these two are the only critical points. Now you have to find the second order derivative. So the second order derivative of this function will be 2 into e to the power 2x. 2 into e to the power 2x minus 5 e to the power x. Yes, you just put down the value of x, once it is ln 2 and the other next time it is ln 3. You see 2 ln 2 means ln to the power 4. Okay, no, I'm sorry. It is wrongly written 2 into ln 2. It means ln of 4. So this 4 should be in the same line of ln. It cannot be the power. Ln of 4. So ln of 4 means e to the power ln of 4 means it is simply 4. So 4 into 2, 8. Okay. Something is missing here. 5 into 2 is 10. So 8 minus 10 is minus 2, which is negative. So there will be a relative maximum at x equal to ln 2. And similarly, when you put x equal to ln 3, you see the value becomes positive. So the function will have a relative minimum when x equal to ln 3. I think this was the last page of this file. So I am going to another file now. Just a minute. Can you see the screen? Can you see the screen? Relative
Yes,
maxima.
miss.
Okay.
Yes, miss.
Thank you. Relative maxima and minima problems. So here the question is what? Find and classify the critical points of the following functions. Here the original functions are given. Determine whether the critical points are relative maximum, relative minimum or neither. Also find the coordinates of the relative maximum or minimum points. So after deciding whether there is a relative maximum or minimum, you have to find the coordinates of that particular maximum or minimum points. So here there are a number, there is a number of functions here. Here I have not done all of them, I have done some of them. And the remaining will be for you to solve. So this is our first function. fx equal to x plus 3 divided by x minus 2. So you see this function is defined everywhere for all real values of x except when x equal to 2, because when x equal to 2 the function becomes undefined because the lower part becomes 0. So that's why this function is defined and it is continuous everywhere except at the point x equal to 2. So now let us find the derivative. Apply the quotient rule. The lower part becomes x minus 2 whole square and the upper part x minus 2 into d dx of the upper part. D dx of the upper part is just 1. Then minus the upper part into d dx of the lower part. So x plus 3 into 1. It will be simply 1. So do the algebra. It is giving you what? In the upper part you have minus 5 divided by x minus 2 whole square. So what is happening here? For a maximum or minimum, relative maximum or minimum of this function fx, either f prime x equal to 0 or f prime x is undefined. Now let us check whether f prime x becomes 0 for any value of x. Please tell me. Is there any point?
No, miss.
No.
No, miss.
No. Yes, because the upper part is simply a constant. It is minus 5. So there is no possibility for f prime x to be equal to 0. So we are not getting any critical point when f prime x becomes 0 because f prime x is never equal to 0. Now let us see where this function derivative is undefined. The derivative does not exist when x equal to 2. But please tell me, can this x equal to 2 be a critical point?
No, miss.
No.
No, miss.
Why?
Because f of x is not continuous
Yes,
as x.
yes, very good. So because since the function is not, original function is not continuous at x equal to 2, the derivative, sorry, the point x equal to 2 cannot be a critical point. For a point to be critical, the original function must be continuous. So what you are getting? You are getting no critical point for this function fx. There is no critical point for this function fx. So that's why there is no relative maximum or relative minimum. So you see, this is a function for which there is no critical point and hence there is no maximum or minimum, relative maximum or minimum. Okay, now the next function. It is x square into x plus 1 whole cube. You see, after if you expand this power 3, it will be a polynomial function, and you know polynomial function is always everywhere defined and continuous. So first we find the derivative, first order derivative. It is a product of two functions, x square and x plus 1 whole cube. So at first we differentiate this x plus 1 whole cube, keeping this x square constant. So x square into d dx of this. D dx of this means 3 into x plus 1 whole square into d dx of x plus 1. D dx of x plus 1 is just 1. So what remains? It will be 3 into x square into x plus 1 whole square. And in the next term, you keep this one fixed, x1 plus x plus 1 whole cube fixed. Find the ddx of x squared. It is 2x. So it will be 2x into x plus 1 whole cube. Okay. So let us now take the common factor. Common factor is x into x plus 1 whole square. So here remains 3x. Here remains 3x and here remains 2 into x plus 1. because x is taken outside and 1 and x plus 1 whole square is taken outside. So here remains 2 into x plus 1. That means 2x plus 2. So these two can be added. So finally it becomes x into x plus 1 whole square into 5x plus 2. So this is the expression for the derivative of the function. Now let us find the points at which this derivative becomes 0 or undefined. You see, f prime x will be equal to 0 when this whole thing becomes 0. So you are getting three values of x. That means x equal to 0, x equal to minus 1, and x equal to minus 2 by 5. Okay, so f prime x will be equal to 0 when x equal to these three values 0, minus 1, x minus 2, sorry, minus 2 by 5. And these 3 points will be also stationary points because these are the critical points of when f prime x becomes 0. And let us check, is there any point where f prime x is undefined? No, because f prime x is defined everywhere because this function is continuous everywhere. It is a polynomial function. So we are getting here 3 critical points. Now, let us find the second order derivative. It will be easy for us because there are 3 points. You may get 1 or 2 points which will give you relative maximum or minimum by testing with the second derivative test. Okay, so what will be the second derivative? This was our expression for the first order derivative. There are 3 factors here. So you keep 2 factors fixed and differentiate 1 factor. So at first I have kept these 2 factors fixed, x plus 1 whole square into 5x plus 2. So x plus 1 whole square into 5x plus 2 into ddx of 1. ddx of 1 is 1. So x plus 1 whole square into 5x plus 2. Then in the next term, you keep this x fixed and 5x plus 2 fixed. And ddx of this x plus 1 whole square, it will give you 2 into x plus 1 into 1. That means the term will be 2x into x plus 1 into 5x plus 2. Yes, this one. And thirdly, you keep these 2 factors fixed, x into x plus 1 whole square fixed. So this ddx of this third factor will give you simply 5. So the term will be 5x into x plus 1 whole square. So this is the technique to differentiate a function which contains 3 factors. You keep 2 factors fixed and differentiate one of the 3 factors, the remaining factor. Okay. So now this is the expression for no need to simplify it. Just keep it like this. No need to simplify. So we will find the value of this second order derivative for these values of x's one by one. At first I have taken this one minus 2 by 5. Minus 2 by 5 means 5x equal to minus 2. You see, when you put 5x equal to minus 2, this factor will be 0. This term will be 0 wholly. And this term will be also 0. So 0 plus 0 plus 5 into minus 2 by 5 into, this is 1 minus 2 by 5 whole square. So this becomes what? 5 cancel out, minus 2, and here remains 3 by 5 whole square, that means 9 by 25. So it is a negative number. So you can make a conclusion here. At the point x equal to minus 2 by 5, the original function will have a relative maximum. Okay, now let us take the at this point x equal to 0. Put here x equal to 0. You see the last 2 terms will be 0. This will be 0, this will be 0, and here it will be simply 2. Yes, if you put x equal to 0, simply 2. So 2 is a positive number. So the function will have a relative minimum at x equal to 0. So you see, you are getting the conclusions easily for these 2 points by using second derivative test. Now what about this point x equal to minus 1? If you put x equal to minus 1, all the terms become 0 and it is 0. So the second derivative test fails because you know when the second order derivative at a critical point becomes 0, you cannot make any conclusion. So for this particular point x equal to minus 1, you have to try with the first derivative test. So let us make a table. Remember, our point is what? Minus 1. So we will take a point which is less than minus 1. So minus 1 minus h, and h is a positive number, h tends to 0. This will be same for each math. H positive and h tends to 0. And we have to check the sign of f prime. Remember, not of f double prime. You have to take the sign, determine the sign of f prime x. What was our f prime x? This was our f prime x. X into x plus 1 whole square into 5x plus 2. So write down this expression for f prime x, and for this point let us put x equal to minus 1 minus h. So this is minus 1 minus h, here minus 1 minus h plus 1, and here it will be minus 5 minus 5h plus 2. I'm taking the minus sign common here, so it will be minus of 1 plus h. Here minus 1 plus 1 cancel out, minus h whole square is h square. And here it is minus 3 minus 5h. Now determine the sign. This minus sign will be there, minus 1 plus h. You see, h is a small positive number and h is positive. So the next factor, the first one negative, second one positive, third one is also positive because there is a square, and this one, you remember, h is positive and h is a very, very small number. So you are subtracting something negative from this minus 3. So the third factor will give you a negative sign. So there are two positive sign and two negative sign in product form. So ultimately the sign will be positive, minus minus plus. So f prime minus 1 minus h will be a positive number. Now let us look for a number which is greater than minus 1. So minus 1 plus h positive and h tends to 0. So just put here x equal to minus 1 plus h. Minus 1 plus h, here minus 1 plus h plus 1 whole square, and here here minus 5 plus 5h plus 2. Yes, minus 5 plus 5h plus 2. So here h is a positive number and very small, very small. So this give you a negative sign. This factor will give you negative sign because h is a very, very small number. This is negative, this will be positive, and since again h is a very, very small positive number, this factor will give you a negative sign. So first negative, then positive, then negative. So ultimately you are getting a positive sign. You see, the value of the derivative was positive when the point was less than minus 1, and this is also positive when the function, when the point is greater than minus 1. So there is no change of sign. Earlier it was positive, after the point minus 1 this is also positive. So there is no change in the sign of the derivative. F prime x does not change its sign at the point x equal to minus 1. So fx has neither a relative maximum or a relative minimum at this x minus 1. This x minus 1 is called an inflection point. Now your question was to find the coordinates of the derivative, the coordinates of the maximum or minimum point. There are two extrema. One is at minus 2 by 5. So you go back to the original function, just put down x equal to minus 2 by 5. This was our original function. Just put here, once you put here x equal to minus 2 by 5, get the value of the function which will give you the ordinate of the point, and the next critical point was 0. Here f of 0 will be 0. So what will be the coordinates of the minimum and the maximum point? The coordinates of the relative, at this point it was maximum. So the coordinates of the relative maximum point will be, here the x coordinate is minus 2 by 5, and this whole thing will be your y coordinate. I didn't put it here, please put it here. And the coordinates of the relative minimum point will be 0, 0, because here the abscissa was 0, x coordinate was 0, and the y coordinate means the function value, this is also 0. So this was our another math. Now let us go to this math.
Miss, y coordinate the f of x থেকে বের করব।
Right. The y coordinate means the function value. You know, fx means y means fx. So the ordinate will be found from what? The function value, original function value.
মিস যদি হচ্ছে সাইন চেঞ্জ হতো তাহলে তো আমাদের এই এক্সট্রা পার্টটা করতে হতো না, লাস্ট যে পার্টটা ছিল।
কোনটা? Which one, the last part?
মিস ফার্স্ট ডেরিভেটিভে যদি সাইন চেঞ্জ হতো, যেমন এই জায়গায় সাইন যদি চেঞ্জ হতো পজিটিভ থেকে নেগেটিভ বা নেগেটিভ থেকে পজিটিভ, তাহলে তো আমরা ওই জায়গায় ম্যাক্সিমাম বা মিনিমাম পেয়ে যেতাম, আমাদের পরের
Right.
পার্টটা করতে হতো না।
কোন পরের পার্টটা? এইটুকু?
নিচের নিচের
No,
পার্টটা।
no, no. This is a must because your question was what? Find the. Let us go back to the question. Yes. Also find the coordinates of the relative maximum or minimum points. So whenever in these maths, if you get a relative maximum or minimum point, you have to find the coordinates there. You see, you have a relative minimum when x equal to minus 2 by 5. Sorry, when x equal to minus 2 by 5, there was a relative maximum. When x equal to 0, there was a relative minimum. So you have to find the coordinates of the point, coordinates of this maximum point and the coordinates of this minimum point.
ওকে মিস।
And for x equal to minus 1, we didn't get any relative maximum or minimum. So that's why we don't need to find the coordinates at this point for x equal to minus 1 because it does not give you any relative maximum or minimum. But for the first two, x equal to minus 2 by 5 and x equal to 0, you have to find the coordinates. Okay, this is our next function. Fx equal to 2x plus 3 into x to the power 2 by 3. It is not a polynomial function because the power is a fraction. It cannot be a polynomial function, but this function is defined everywhere because you will get a finite value for every real finite value of x. So this function is defined everywhere. Now let us find the derivative. The derivative will be, for the first term it will be 2 and for the second term it will be 3 into 2 by 3 into x to the power 2 by 3 minus 1. 2 by 3 minus 1 means minus 1 over 3. Here 3 cancel out. You can take 2 common. So it will be 2 into 1 plus this is negative power. So let us take it to the lower side. X to the power 1 by 3 means cube root of x. So let us check at which values of x this derivative becomes 0 or undefined. This will be equal to 0 if cube root of x equal to minus 1. Yes, because if this is minus 1, 1 by minus 1 means minus 1 and minus 1 plus 1 gives you 0. So if cube root of x equal to minus 1, then the derivative will be equal to 0. So this minus 1 is a critical point and it will be a stationary point. Now, for what value of x this derivative will be undefined? You see, this was the expression. Here it will be undefined when x equal to 0. Isn't it? Because when x equal to 0, this becomes infinity, 1 by 0 infinity. That means f prime 0 becomes undefined. So x equal to 0 is another critical point and it can be a critical point this because this function was continuous everywhere. It is also continuous at x equal to 0. When x equal to 0, the function value is 0. So f of 0 is a finite value which is 0. So x equal to 0 is another critical point. So here we have two critical points. One is 0 and the other is minus 1. Okay, let us now find the second order derivative. This was our expression for the first order derivative. So it will be what? Derivative of 1 is 0, so it will be 2 into derivative of this thing. Yes. ddx of 2 into 1 over cube root of x. 1 over cube root of x means x to the power minus 1/3. 2 can be taken outside and ddx of this will be minus 1 by 3 into x to the power minus 1 by 3 minus 1. That means minus 4 by 3. So it becomes what? Minus 2 by 3 into 1 by x to the power 4 by 3. I am taking it to the lower side because the power was negative. Okay, this is the expression for the second order derivative. Now you check the value of the second order derivative for the two critical points. So the first point was minus 1, just put here minus 1. Put here minus 1. Here the power is 4 by 3. At first if you take the power 4, minus 1 whole to the power 4 is plus 1. And 1 to the power 1 by 3, it is a positive number 1. So ultimately the result is a negative number. So the function will have a relative maximum when x equal to minus 1. And what happens when x equal to 0? Put here x equal to 0. Yes, the second order derivative becomes undefined. So the second derivative test fails here. So we will try with the first derivative test when x equal to 0. So let us make a table here. Let us make a table here. So one point should be 0 less than 0 and the other point should be greater than 0. So 0 minus h and 0 plus h. In both the cases, h is positive and h tends to 0, very small positive number. This is the expression for the first order derivative. So you just put here x equal to 0 minus h. So it will be 2 into 1 plus 1 by cube root of 0 minus h. So what will be the sign of this term? You see, 0 minus h means cube root of minus h. H is positive, so minus h is negative. So cube root of minus h will be a negative number. Will be a negative number, and the expression will be like this: 1 minus 1 by h to the power 1 by 3. Now, what will be the sign of this whole thing? It will be negative. Why? Because h is a very, very small number. So if you divide this one by a very, very small number, suppose 1 divided by 0.0000005, ultimately 1 divided by 0.00005 will be greater than 1. So that's why this number will be negative. So f prime 0 minus h will be a negative number. Now let us check when x equal to 0 plus h greater than 0. So here it becomes 1 by cube root of 0 plus h is positive. So there will be a plus sign. It may be greater than, it is greater than 1 of course, but the whole thing becomes positive because 1 plus something. So the sign of f prime 0 plus h is positive. So it is changing its sign from negative to positive. So there will be a relative minimum when x equal to 0. Yes, when x equal to 0, the function will have a relative minimum, and the minimum value of the function when you put x equal to 0, yes, the original function was 2x plus 3x to the power 1/3, so it is 0. So the coordinate of the minimum point are 0, 0. And what will be the coordinate for the maximum point? X equal to minus 1 was the x coordinate. So let us put in the function x equal to minus 1. 2x plus 3 into x to the power 2 by 3. Just put minus 1. This will be negative. Oh, no, positive. Minus 1 whole square, it is positive. So it is minus 2 plus 3, it is 1. So the coordinate will be minus 1 and 1. These are the coordinates for the relative maximum point. Okay. There is another question, but actually the question is same. Question is same, and these are the functions. These are the functions. Here also I have not done all the maths. I have done a few of them, and the remaining parts will be for you, for practice. So here, this is a polynomial function you see, which is continuous everywhere. So let us find the derivative. By now, you know how to find the derivative. You take x cube common, and these are the factors. So f prime x will be 0 when x equal to 0, x equal to minus 1, and x equal to minus 2. So these three, 0, minus 1, and minus 2 are the critical points, and they are also stationary points. And here, f prime x is also a polynomial function. So there is no point where f prime x is undefined. So there is no other critical point. The critical points are only 0, minus 1, minus 2. So now to use the second derivative test, let us find the second order derivative. It will be 5 into 30 x to the power 4. That means 150. Okay. It will be 150 x to the power 4, and then 360 into x cube plus 180 into x square. So if you take x square common, it will be like this. Now, for the first point, x equal to 0. 0 minus 1 minus 2. For the first point x equal to 0, yes, f double prime becomes 0. So no conclusion here. So you have to test the first test with the first derivative test. So the first point is 0 minus h, and the second point will be 0 plus h. H tends to 0 and h is positive. So what was the expression for f prime x? I have not written here. The expression for this was the expression. F prime x is 30x cube into x plus 1 into x plus 2. So 30 into 0 minus h whole cube minus h plus 1 minus h plus 2. Yes. So this gives you a negative sign. Minus h whole cube means minus. Minus 30h cube, 1 minus h. H is a very small number, positive number. So this part will give you positive. This part will be also giving you positive. So negative, positive, positive. So negative, positive, positive, ultimately it is negative. And if it is positive number, 0 plus h. So 30 into h cube, h plus 1, h plus 2, all of them are positive, 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 positive. So the whole thing becomes positive. So it is changing sign from negative to positive. So there will be a relative minimum at x equal to 0. And the minimum value is minus 10. So the coordinates will be 0, minus 10. F of 0, it is minus 10. Go back to the original function. Yes, if you put x equal to 0, the function value is minus 10. So the coordinates of the relative minimum is 0, minus 10. Now let us put x equal to minus 1. So if you put x equal to minus 1, ultimately it gives you a negative number. If double prime minus 1 is negative, so there will be a relative maximum when x equal to minus 1. And the maximum value, go back to the original function, it is a negative number. So the coordinates are minus 1, minus 8. It is not written clearly here. Please, you include the coordinates. It will be minus 1, minus 8. Now, I think there is some mistake here. After taking the images, I found that there was a mistake. F prime double 2, you cannot go back to the original function. You have to put here. If you put f prime equal to, x equal to minus 2, what will happen? This term will be positive, minus 2 whole square. It will be what? 5 into 4, that means 20. 20 minus 24 plus 6. That means this part will give you 4 and this part is positive. Ultimately, it will be a positive number. So at x equal to minus 2, there will be a relative minimum. It is not written here because this is wrongly done here. F double prime minus 2, the value is, it was 4, I think, which is a positive number. No. 30 into 4 into 4. 30 into 4 into 2. That means 240, so which is a positive number, so there will be a relative minimum. So you please find out the coordinates of this relative minimum point. Now let us do this math. This is important, you see. This is a rational function. This is a rational function, and this function is defined and continuous everywhere except at x equal to 10. Except at x equal to 10, because this function is undefined at x equal to 10. Okay, so let us find the first order derivative. X minus 10 whole square, and in the upper part it will be x minus 10 into d dx of this. D dx of this will be 2x minus 7 minus this upper part into d dx of the lower part. Upper part is x square minus 7x plus 6 into d dx of x minus 1 is just 1. Do the algebra, multiply these two factors, do the algebra, and ultimately you are getting this. So you see f prime x, f prime, yes.
মিস আমরা তো ফার্স্ট লাইনে যেটা উপরে ওই জায়গায় মিডল টার্ম করে দেন তো ফার্স্ট ডেরিভেটিভটা করতে পারতাম, তাই না?
But here,
জি মিস, প্রথম লাইনে যদি আমরা হচ্ছে x স্কয়ার মাইনাস 7x প্লাস 6 কে মিডল টার্ম করে ভেঙে ফেলি।
Okay. It is up to your choice. It is up to your choice. You can find the derivative anyway. You can follow any method. Okay. So here the function, derivative of the function will be 0. If the upper part is 0, that means when x equal to 4 or x equal to 16. So these 4 and 16 will be the critical points, and they will be also the stationary points. Now, f prime x is undefined. It does not exist when x equal to 10. But this x equal to 10 cannot be a critical point. Why? Please answer me. Why x equal to 10 cannot be a critical point?
মিন্স ওটা তো নিচে 0 হয়ে যাবে, তখন আনডিফাইন্ড হয়ে যাবে।
Here f prime x is undefined when x equal to 10. But can you take this x equal to 10 as a critical point?
Yes, miss.
It's continuous.
টেনটাকে উপরে বসাইতে হবে।
Huh?
X is equal to 10 is a critical point. It's not stationary. That's it.
No. It
And
cannot be a critical point.
Function to
X equal to 10 cannot be a critical
If it is not continuous, then it
Yes.
cannot be.
fx is not continuous.
Right. Because the original function was not continuous at x equal to 10. A point at which the original function is not continuous, that point cannot be a critical point. So here x equal to 10, though f prime x becomes undefined at x equal to 10, it cannot be a critical point because at x equal to 10, the original function was not continuous. So you have to be very, very careful. X equal to 10 cannot be a critical point. We have only 2 points at which the function, derivative of the function becomes 0, 4 and 16, and these are the stationary points also. So here I have followed the first derivative test in the very beginning. So the first point was x equal to 4. I have taken a point which is less than 4 and then which is greater than 4. So 4 minus h and 4 plus h. Here h is positive and h tends to 0. So what was our expression for first derivative? So here you just put for the first point 4 minus h, you just put 4 minus h here and 4 minus h here, 4 minus h here. So 4 minus h minus 4, 4 minus h is minus 16. Here 4 minus 4 cancel. So minus h into what? Minus h minus 12. And divided by, it will be minus h minus 6 whole square. So whatever be the number here, since there is a whole square, the lower part is a positive number. The lower part must be a positive number, and the upper part, there are 2 factors. Minus h. H is positive, so minus h, it will give you a negative sign, and minus h minus 12. H is a positive number, remember, minus 12. So again, you are getting another minus sign. So in the upper part, 2 negative signs. So ultimately, the upper part becomes positive, positive by positive. So ultimately, f prime x, you can write it here 4 minus h. F prime 4 minus h is a positive number. Now let us check for x equal to 4 plus h. So 4 plus h minus 4, 4 plus h minus 16 divided by 4 plus h minus 10 whole square. So this becomes simply h, and here h minus 12. So h, it gives you positive sign, and h minus 12, which will be negative because h is positive and h is a very, very small number. So it will give, this factor will give you a negative number. So positive into negative divided by, definitely it will be a positive number. So ultimately the sign of the derivative becomes negative. Negative by positive, so negative. So you see the derivative of the function is changing its sign from positive to negative. So there will be a relative maximum at x equal to 4. Relative maximum at x equal to 4, and the maximum value of the function will be like this. You just put x equal to 4 in the original function, the value is 1. So the coordinates of this relative maximum point is 4, 1. Now we check for the second point, x equal to 16. X equal to 16, so 16 minus h and then 16 plus h tends to 0, which is a positive number. So the technique is same. You just put down the value of x like 16 minus h here, and here 16 plus h. Now check the signs. This is important. It will be 12 minus 8. This will be definitely positive, and here 16 minus 16 cancel out because here the factor was what? X minus 16. Yes, the factor was x minus 16, and the value of x is 16 minus 8. 16 minus 8. So 16, 16 cancel out. It is 12 minus 8 into minus 8. This will be positive and this will be negative. So positive into negative divided by, there is a whole square. So definitely it will be positive. So ultimately it is negative. And what happens when it is 16 plus h? 12 plus h, so it is positive. 16 minus 16 cancel h, so plus into plus divided by plus. So the sign is positive. So it is changing its sign from negative to positive. So there will be a relative minimum when x equal to 16. Relative minimum when x equal to 16, and the minimum value, you just put down x equal to 16 in the original function, it is 25. So the coordinates will be 16, 25.
মিস 10 নাম্বার পেজে যে লাস্ট ম্যাথটা ছিল সেখানে যদি মিস এমন হতো যে ক্রিটিক্যাল পয়েন্ট এন্ড হচ্ছে স্টেশনের পয়েন্ট আলাদা করে হতো, তখন হচ্ছে আমি কি ফার্স্ট ডেরিভেটিভ টেস্টটাই এর নিচে মিস একটু নিচে
Page number 10.
10 এর নিচে মিস, হ্যাঁ এই এটার নিচে
Okay, in this page, হ্যাঁ,
নিচে মানে হচ্ছে 11 নাম্বার পেজ তাহলে।
okay, 11 number page.
মিস
So
এখানে যেমন হচ্ছে 4 এন্ড 16 হচ্ছে আমরা ক্রিটিক্যাল পয়েন্ট যেগুলো স্টেশনারি পয়েন্ট, যদি এমন হতো যে না 16 স্টেশনারি পয়েন্ট আর 4 ক্রিটিক্যাল পয়েন্ট,
it doesn't matter. It doesn't matter. Tomar, if it is a stationary number, the method does not change. The method does not change. Method is exactly same.
f prime x আমরা কি ক্রিটিক্যাল পয়েন্ট বসাবো নাকি স্টেশনারি পয়েন্ট বসাবো?
Stationary points are critical points. So the
No.
method is not changing. Method will be same whether it is stationary or simply critical, because you know the classification is only for decide whether the critical points are stationary. That's all. But the remaining steps for finding the relative minimum or maximum, it does not change. It will be the same thing. The method does not change. The method is not different for critical or stationary, because stationary points are also critical points. So the method is found for critical points, not separately for stationary points. All the methods are for critical points to decide whether the critical point is a maximum or minimum point. So that the method does not change. Okay, no change in the method. I think this is the last one anyway. So this is again a rational function. You see, x cubed divided by x to the power 4 plus 1. So please tell me, please tell me, is there any point where this function is undefined?
মিস x টু দ্য পাওয়ার 4 হয়, তার মানে হচ্ছে হবে না মিস, আনডিফাইন হবে না।
Yes.
So means it's a positive power, so
Yes, the lower part is always a positive number because the minimum value of x to the power 4 is 0. X to the power 4 cannot be a negative number, and the minimum value of x to the power 4 is 0. So the lower part cannot be negative, cannot be 0 for any value of x. That's why this function is continuous everywhere. Though it is a rational function, it is a continuous everywhere. Okay, let us find the derivative. X to the power 4 plus 1 whole square, x to the power 4 plus 1 into ddx of x cube, 3x square, then minus x cube into ddx of this. So x cube into 4x cube, right? Now do this simple algebra, multiplication and subtraction, addition. Finally, you are getting this. So here you see, you can take x square common. So x square into part 3 minus x to the power 4 divided by this. So you see f prime x exists everywhere because there is no point where f prime x is undefined. It exists everywhere. So the only critical points will be, we will get the critical points only when f prime x equal to 0. And f prime x will be equal to 0 if the upper part is 0. That means if x equal to 0 and x to the power 4 equal to 3. These are the two critical points, x equal to 0 and x to the power 4 equal to 3. That means x will be equal to plus minus 4th root of 3. There will be two values, either positive or negative, because the power is 4. Power is 4, so the solution may be positive, may be negative. So there are 2 points here, plus minus 4th root of 3. That means 3 to the power 4. So actually we have 3 critical points, 0 plus 3 to the power 1 by 4 and minus 3 to the power 1 by 4. And all of these points are critical points. Okay, I am trying with the first derivative test. So the first point is 0. So 0 minus h and 0 plus h. What was our derivative? This was our derivative. This is our derivative. So you just put x equal to 0 minus h. So minus h whole square, 3 minus h to the power 4 divided by h to the power 4 plus 1 whole square. This is a whole square. So this factor will be positive. H is a very, very small positive number. So this factor will be also positive. So positive by whole square, so positive. So it is a positive. The derivative at 0 minus h is a positive. Now you take 0 plus h. So 0 plus h whole square into 3 minus h to the power 4. H minus h and plus h is, since the power is 4, it will be h to the power 4. So this factor positive, this factor positive, positive by positive, this is also positive. So you see there is no change in sign. There is no change in sign. So there cannot be any relative maximum or minimum at the point x equal to 0. Okay, now you test for 3 to the power 1 by 4. 3 to the power 1 by 4 minus h and 3 to the power 1 by 4 plus h. So after putting the values of this x in the derivative of the function, 3 to the power 1 by 4 minus h whole square, 3 minus, there was x to the power 4. It was x to the power 4. So 3 to the power 1 by 4 minus h whole to the power 4. So this is a whole square. Definitely it will be a positive number. And what happens here? You see, h is a very, very small positive number. So this number will be less than 1 by 4. So if you subtract something positive from this, it will be less than 3. Because if there is no h here, after taking the power 4, it would be 3. So 3 minus 3 would be 0. But you are subtracting something positive from this. So it will be less than 3. So this part will be a positive number. 3 minus something which is less than 3. So it is a positive number. So the lower part is a whole square. So ultimately all the things are positive. So the derivative here is positive. Now you take 3 to the power 1 by 4 plus 8. This is a whole square. So definitely it will be positive. And what happens here? You see, it is 3 to the power 1 by 4 plus h whole to the power 4. If this h is 0, it will be what? 3. That means 3 minus 3, 0. But you are adding something positive to this 3 to the power 1 by 4. That means this whole thing will be a number which is greater than 3. So ultimately this factor will give you a negative sign. So positive, negative divided by positive, ultimately it is negative. So there is a change in sign from positive to negative. So there will be a relative maximum at x equal to 3 to the power 1 by 4. There is a relative maximum here. And now let us check for what? Minus 3 to the power 1 by 4. Same thing. This is a whole square. This was x. X square into 3 minus x to the power 4 divided by, what was it? Divided by, what was it?
Plus 1.
X to the power 4 plus 1. So if you put x equal to minus 3 to the power 1 by 4, it will be simply 3, right? It will be simply 3. So this part is important to decide the sign of the factor. So this is a whole square, so it will be positive. Now what happens here? The whole power is positive, okay? And you are subtracting something from this minus 3 to the power 1 by 4. So this thing is less than 3. This will give you a number which is less than 3 because it is, you are subtracting something positive from this number. So the second part will be positive. Oh no, it will be negative. Why? It will be negative because if you take a minus sign common, minus sign whole to the power 4, it is positive. So 3 minus 3 to the power 1 by 4 plus h whole to the power 4. So definitely this number will be greater than 3, so it will be a negative number. So positive into negative divided by positive, so ultimately it is negative. And what happens here? It is minus 3 to the power 1 by 4 plus h. So again, I am taking a minus sign common because it will help you to determine the sign. Take minus sign common. Minus sign whole to the power 4. It gives you positive sign. So this sign is not changing. And ultimately, when you take minus sign common, it will be 3 to the power 1 by 4 minus 8. So this number is less than 3. This number is less than 3, so it will be positive. Positive into positive by positive, so positive. The previous one was negative, so there is a change in sign from negative to positive. Okay, so there will be a relative minimum here, and you can easily find the coordinates of the point. Okay, there is a math here. Another math. I think not the previous one was the last. This is the last one. Okay, we have some time. Let us go through this one. So you see this function is continuous everywhere. Though it is not a polynomial function, it is continuous everywhere. So let us find the derivative. ddx of the first function, 2x. 2x into this plus x square into ddx of this. So 2 by 3 into x minus 1 whole to the power minus 1 by 3 into x square. So let us do some algebra. It is 2 by 3 and you take this to the lower side. So upper part will be 2x square by 3 into x minus 1 whole to the power 1 by 3. So this is your LCM. And 2 by 3 plus 1 by 3, it gives you just 1. So 3 into 2 is 6. 6x x minus 1 plus 2x square. So after doing the algebra, you can take 2x common. So 2x into what? 4x minus 3. So you see this derivative becomes 0 when x equal to 0 and when x equal to 3 by 4. Yes, x equal to 0 and x equal to 3 by 4. These two are the critical points, also stationary, and it is undefined when x equal to 1. X equal to 1 will be another critical point because at x equal to 1, the original function was continuous. So x equal to 1 can be the third critical point. So in total, there are 3 points which are critical. X equal to 0, 3 by 4, and 1. So here also I have done all the tests with first derivative test. So at first x equal to 0. Just put x equal to 0 minus h. It will be negative. This is also negative. Negative by negative because the power is 1/3. If you take the 1/3 power of a negative number, it is negative. So upper part is positive by negative, that means negative. So f prime 0 minus h is negative. Now you take x equal to 0 plus h. So 2 into h, it is positive. And here 4h minus 3. This 4h will be less than 3 because h is a very, very small positive number. So minus 3 plus something positive, very small, it is giving you negative number. Positive into negative divided by negative. Why negative? Because h is a very, very small number. The lower part is negative. When taken 1/3 power, this will be also negative. So minus minus, it gives you plus sign. So the sign is plus. So there is a change from negative to positive. So there will be a relative minimum at x equal to 0. And the minimum value is 0. So the coordinates are 0, 0. Now you take if x equal to 1 minus 8 because another point was x equal to 1. X equal to 1. I avoided the second derivative test because it is little complicated to find the second derivative of this function. That's why from the very beginning I have done the test with first derivative test. So here x equal to 1 minus h, h positive, h tends to 0. So 1 minus h into 4 minus 4h minus 3. So 1 minus h, this will be definitely positive, and 1 minus 4h. H is a very, very small number, so this will be also positive. So positive into positive divided by 1 minus 1 cancel out, minus h whole to the power 1/3, which is a negative number. So positive by negative, it is negative. So this is negative. And now you take x equal to 1 plus h. This is positive. 1 plus 4h. This is also positive, and the lower part is also positive. So the whole thing is positive. So again, you are getting a change in sign from negative to positive. So there is a relative minimum. The previous one also, yes, the previous one also relative minimum. So we have two relative minimums here at x equal to 0 and x equal to 1. Now what happens for x equal to 3 by 4? 3 by 4. So 2 into 3 by 4 minus h and 4 into 3 by 4 minus h. That means 3 minus 4h, right? Because h should be multiplied by this 4. So what is happening? H is a very, very small number, so it is definitely less than 3 by 4. So this part will be positive. And here 3 cancel out. H is positive, so minus 4h give you negative. So positive into negative divided by this 3 by 4 minus 1. That means it is minus 1 over 4. And so it is a negative number. And negative number whole to the power 1 by 3, it is also negative. So ultimately, it gives you positive. So f prime 3 by 4 minus h is positive. Now, 3 by 4 plus h. So the first one is positive. Second one is also positive. And the lower part, h minus 1 by 4. H is a very, very small number, so it is a negative number. So upper part positive, lower part negative, ultimately it is negative. So here also it is ultimately negative. So here we are getting a relative maximum because the derivative is changing its sign from positive to negative. So there will be a relative maximum at x equal to 3 by 4. And the maximum value is this. So the coordinates of the point will be 3 by 4, 0.4. I think this was the last one. This was the last one of this file. So please try to do the math, the remaining maths here.
Miss,
Just a second. I have done here only the tick marks. The tick marks are done here. So there are maths remaining. There are maths remaining. Please try to do. I think we have done this one also. Number 9 also done. So please try to do the remaining maths, and also in the first page of this file there are maths also. Yes, here. You can, here we have done this one, and this one. Oh, only 3.
Yes, are these maths taken from the book?
No, not all of them are from the book. Not all of
Yes,
them are
we-
from the book. I'm giving you some maths. Just a minute. Just a minute.
Miss, did you take the attendance?
Okay, I'm sorry. I'm very sorry. I forgot. I forgot. Oh, sorry. So here, I need to stop the presentation.